Hello, welcome back to NMI. In this video, we're going to take a look at this guy, TRS-80 Model 2, with this big 8 inches floppy drive. This machine is not working at all, and I got it last year for I think 40 bucks, and I'm going to have to completely disassemble it and understand why it's not working and try to fix it. I believe this video is going to be very cool, so let's take a look. So here we can see the keyboard, and you can hear that there's stuff broken inside. I honestly did not open it yet because I was doing other stuff. The keyboard connects here. There's this plug here, this connector, and then there's this plug. I believe there was some kind of spring mechanism that it's not working anymore. So that's something I'm gonna have to fix somehow. The big 8 inches floppy drive, and I already connected power back there. Let me show you. First of all, let me show you the back of this machine. It's heavy. Here we have power, right? 2 serial channels, a parallel printer channel, and a disk expansion. Yeah. And here we have a fuse. The fuse are already checked and it's good. Now let's connect the power cord. And if we power it up, this noise is because the floppy drive here is always spinning, and I believe the motor that spins the disk is connected to the AC. So yeah, it's an 8-inch floppy drive and it's super noisy. I don't know if it's supposed to be noisy like this. I don't think so, but who knows. Anyway, you can see that there's nothing on the screen, and now we're gonna have to open it up and look inside. There are 2 screws here and here, so I need to remove them. I already opened this machine once just to take a quick look inside, and I applied power back then and it didn't work, so I decided to not touch it anymore until I had enough time, and the time is now. Look at this. I'm gonna turn on the other camera so that you can check it out. So here we have it. It's super dusty. We have the power supply here. Oh yeah, I think you can see it. I think this is the CRT controller or the analog board here. Then we have some sort of backplane here, and 5 boards, and a gigantic 8 inches floppy drive here. Yeah, this is I don't know. I never, honestly, I have never seen an 8-inch floppy drive. That is the first time I have a machine. Never used them before, so yeah. Uh, yeah. The first thing I want to do, I'm gonna remove. I think the right thing to do is to just remove everything and clean. Start by cleaning up. We already know that it's not working, right? So I'm gonna try to remove these two nuts here and see if we can remove the boards, take a look at them. Okay. So here we have one card. This, yeah, it had this connector. Oh. There's a bodge wire there. So this was already repaired. See, I don't know if you can see, yeah. Here. Yeah, that's not very good because I don't know what kind of repair happened. The capacitor? 150 volts? No, 50 volts, okay. Still very high voltage. Yeah. So this is probably the 6845, the video controller chip. They're very stuck. Yeah, this is a RAM card. What kind of IC? Oh yeah, 4116. So we have 16, 16, 16, and 16. So 64K here. And what else we have here? Oh, another RAM card. These memories, they have a different part number. BCM 972, 90072. Yeah, I am a bit confused because well, maybe these machines can support 128K, but I'm not too sure. Yeah, so this is the floppy drive controller. We have a Z80 PIO here, a parallel I/O chip, and this is the floppy controller FD1791. And this one probably is the CPU. Whoa, lots of Zilog ICs, or yeah, we have at least, yeah, we have 4 40-pin Zilog branded chips. I am not sure which one of them is. Probably the Z80. I am not sure which one because I don't recognize the markings, but yeah, this is probably the RAM card, or sorry, the CPU card. And yeah, the backplane is there. It's very dirty. Oh, the nut is here. Now I need to find a way to disassemble this whole thing because I am not sure. I see some screws here, but I don't have a way to access them. So I'm guessing that this whole thing can be removed. Yeah, So that's the next thing I'm gonna do. Okay, let's power it on. And this here is the wire that goes to the CRT here, and there is nothing. So either it is shorted there, or 4.9, so 5 volt is okay. 5 volt is okay. 13 volts, this is slightly higher than it should. This should be 12. 4.8. Yeah, this yellow here, 27. This is too high, it should be 24. Yeah, so this power supply, yeah, now let's see something. I'm gonna power it off. Let's remove this the connector here, and now there's no power to the CRT board. And if we power it on, let's see what is the voltage there. Oh, see, so 13 volts. So there is a short there. So now we know what to look for. There is a short on the analog board, or like the CRT board. This is the front panel, and yeah, I had to clean. I still need to do some minor cleanup here, but it's cleaner now. There's no dust. One thing that I want to do is to check the LED, because the LED is not lighting up, and I don't know if the LED is damaged, or maybe it's just the CPU board. I'm not too sure. So just to avoid confusion, let's test it right now, so we're gonna know. See, okay, good news, kind of. Right. I would rather the LED be damaged than the CPU board working, but yeah, at least now we know that the LED is working, and if it's not getting lit properly when the machine is working, it is on the CPU, right? Now looking at the PCBs, this is the power supply. I try to clean it up a little bit. We can see here, this is a switch mode power supply. These are the big input capacitors. I believe only one of them is in use when the power supply is configured for, or configured to work on 110 or 120 volts, which is the case now. This is probably the transistor on the primary of this transformer, so it switches the transformer. And then on the secondary we have all the output rails, so this is why we have all these diodes here, including this big diode. That's a that's a big diode here. Yeah, and this is the connector for the output. One thing that I noticed here is that the two 12-volt outputs, they are connected together, right? So that means that if the CRT is shorting, we should see also a short on the other 12 volt. I don't recall it clearly, but I think I was seeing only one rail going to 0 volts. So we need to check that again. Maybe it's not the CRT that is in short. Maybe this power supply, the 12-volt rail here, has some issue. And yeah, this is it for the, let me see. I don't see any bulged capacitor or anything that looks leaking. There is some black stuff goo there, but I think that is just some kind of glue that they apply. I'm not too sure. We can take a look at that later. Yeah, but this is the power supply. It's a nice power supply, by the way, right? The brand Aztec is really good, and I believe it's the same power supply that I have on my Apple II E. No, or the 2 Plus, I'm not too sure. But yeah, it's a good brand. They have this control module here that basically takes the output reference from the power supply and controls the switching of this transistor. So all the magic happens here. It's a pretty cool, pretty good design. Very interesting. It's old, right? Because now we have ATX or even AT power supplies. They're half of the size and much higher current. But yeah, this is 80s design. And here we have the analog board that drives the CRT. We have the flyback capacitors. This is probably the horizontal transistor. And oh yeah, there's another transistor here. Yeah, so maybe one thing that we can do is to power this board with 12 volts from my power supply, and have the CRT here and everything, and just to make sure that there's no short, and maybe we're gonna see some kind of action on the CRT. That is something that we can potentially do. Otherwise, the next thing I'm gonna do is just to make sure that there's no short here, and then we need to look at the power supply, right? And here we have the boards, the PCBs. This is the backplane, right? Yeah, I believe it's installed like this. So the power comes here. There is a filtering capacitor that is still a little bit dirty. Yeah, some more capacitors here. This seems to, oh, there is the voltages are written down here. So this board takes, or the backplane takes -12, +12, and +5. So it's a good thing that we can just measure them here. Yeah, that's interesting. Maybe I already applied some contact cleaner. The slots, like the connectors, they look really good. I don't see any, sign of wear off or anything that might, cause a malfunction, but who knows. Here we have the CPU card. Oh, there's still some pieces of cloth that I used. This is the CPU card. I now know that this is the Z80. I looked up. I still don't know which one is the DMA. One of these two is the DMA controller. There is another, well, I don't know what are those two, and this is a ROM. Yeah, not much to see here, except for the fact that this is where the power goes to the LED, right? And maybe one thing that we could do is just to follow this track. Oh, see, there is a resistor here, 330 ohms. So yeah, so this is driving the LED, and this is probably they're connected to the 5-volt rail. Let's take a look. Now, if there is no, the LED is not lit, that means that the 5-volt here is dead, right? So let me see. Which one is the +5? From what I recall on the TTLs, this is, so this should be ground, and this is ground. Yeah, so this is ground. Yeah, and this is +5. And one of these here, yeah, this one is +5. This other one, oh, this is ground. Okay, yeah, this is ground. Oh yeah, it's clear here. The capacitors are connected to the ground here. Yeah. So yeah, so that's either this, let's measure this since we are here, right? Let's just make sure that this, yeah, I don't know what I'm doing here. Let's see if we see 330 ohms here, and we see it's fine. So the conclusion is there's no 5-volt powering this board, right? Either, well, at this point I believe the power supply is shutting down, right? Because we saw that the power supply is working. So maybe there is a short somewhere, maybe one of these boards. Yeah, that's what I'm gonna have to find out. Okay, now we have the CRT here. I reconnected the flyback. I reinstalled the yoke. The wires were here. I reconnected this socket here and reinstalled the connector here. And this is the power input, right? Now I'm gonna adjust the power supply to 12 volts. The current I am gonna limit in 1 amp. Yeah, let's see, 1 amp should, now let's start with 500 milliamps just in case. Okay, so the current is limited. Now I'm gonna power it off and connect. Okay, power it on. Oh, nice. Okay, so the CRT seems to be working. Now at least we have a glow there. It's draining 152 milliamps. Okay, it's time for us to check the power supply. Here we have the schematics, and we can see that this area here is the 5-volt rail, right? And it provides, oh, this B plus here has some feedback here, right? And this R13, I think I saw it here. Oh yeah, see R13 there? That is for the feedback, and it allows adjustment of the voltage output. I don't know exactly, maybe it's written here, but I don't know exactly how, like if they have values or you have to just try different resistors here. But so this allows you to adjust the output, maybe except for the -12, because here we have a regulator already. But for these other rails, +24, +12, and +5, these are all direct outputs, right? From the switching power supply. So the feedback, is there an, oh, there's another feedback of +5 here. Oh, and there is this feedback. Is this a feedback? There is something coming from +12, but it goes through C32. Yeah, it's hard to read the silk screen. Yeah, I guess I'm gonna have to remove some components and try to find. Maybe we need to, yeah, the usual thing would be to measure these capacitors, right? Because especially the capacitors here on the output stages, C23 for the +12, C24 for the +5. These are, oh, C23, this is the 12-volt one. So we're gonna start with this one. And here we have our capacitor, 1000 microfarads, 25 volts. Just a heads up, always remember to discharge the capacitor before testing, because this is not high voltage, but sometimes like the capacitors that are connected to higher voltage, they will damage your testing device if you do not discharge them. 1000 microfarads, ESR is good, voltage loss 1.1%. Yeah, let's say this is good. Maybe what I should do now is to just connect everything back and measure everything again, right? Because I want to make sure that the power supply is, oh, by the way, yeah, I was gonna say that the power supply is shutting itself down, and that happens around this area if there is, but this is for the over voltage. By the way, let me see something. I'm not too sure. I saw something on current sensing. Yeah, there's no current sensing, but You know what? One thing, I'm gonna check the 5-volt rail, the whole rail, and in special these guys here, because we're not seeing 5 volts there, right? And if this protection is getting triggered, it would short the 5 volt, and then that would explain why we don't see the LED coming on, right? So this is one thing that I'm gonna do. There's a diode, there is a Zener, a resistor. Okay, so I'm gonna remove that Zener and test it. So, oh, did I break the resistor? Huh. Well, okay, we're gonna have to replace it. I don't think I did. So here is half or a third of the resistor. Now let me get the other 2/3 here. And I also want to get the Zener. But now my focus is on this guy. I'm gonna need to replace it. What is that? Brown, red, black. Let's check the Zener here. I don't know if this tester can do Zener. Let's see. Yeah, it looks like, oh, but this is just testing as a diode. I don't think it's gonna make any difference. Reversing the pins. Yeah. Maybe I'm gonna have to use my bench power supply. I'm gonna set a very low current. Yeah, maybe I should. Yeah, I'm gonna record so that you can see how I usually test Zeners. But okay, now I need to find another resistor to replace this guy. Okay, I think that is a 12 ohm resistor or 1.2, I'm not too sure. Let me check. Fun fact, when I migrated to Canada, I attended Conestoga College. That was like 8 years ago. And one good thing I got there is this resistor kit. And it has the 12 ohm somewhere here. And that's very handy because usually I would not have this kind of resistor, right? If it wasn't for this kit. By the way, shout out to Alan and to Mike and the other professors there. Well, Mike is not there anymore, but great team there. And here we have 12. Good. Thanks to my Conestoga resistor kit. Okay, now I have the resistor here. Let's take one. At some point I might have to buy another one of those because They're handy when you're repairing. Maybe there is one of those for capacitors. That would be cool. Yeah, that would be a good idea, right? I need to check. Abra. Okay. Now let me show you how we can test the Zener. Okay, you're now seeing my power supply, which is a very low cost one. I apologize. Maybe at some point I will get another one, but that's all I have now. So what I am gonna do, I'm gonna power it on. Here we are in the current settings. I'm gonna, yeah, this encoder needs some love. This rotary encoder, sometimes it doesn't work like this. I'm gonna set it to 20 milliamps, like this. And then yeah, man, this rotary encoder is bad. Okay, now I'm gonna supply power, and you connect the diode, the Zener reversed, right? Like this, right? Positive on the cathode, and we increase the voltage until we see that at some point the Zener, when it reaches the Zener voltage, we should see the current get limited, right? And this Zener should be slightly above 5 volts, the Zener voltage, right? So we are at 5. I didn't read the, oh, here we are. See? So now it's limited at 5.76 volts, right? That is the Zener voltage of this diode here. You don't want to use the too high current, yeah, because you can damage the Zener. And yeah, so this Zener is okay. So a 5 point, okay, let me go back to the other camera. So 5.76 volts here, or like a voltage of 5.76 should trigger this Zener and cause this SCR to short the 5 volt rail, right? Now this is okay, this Zener, but when I was removing the parts here, I ended up breaking the resistor. I honestly don't know. I don't think I broke it. Maybe it was broken already. And in that case, I wonder, well, it wouldn't, I need to check. I honestly need to, I'm gonna go back to the diagram. Everything is back in place. And we have a new resistor here. As you can see, the previous one is no more. I don't know. Did I do this? I'm not too sure. Maybe I did. I don't think so. And in that case, maybe this was the reason this power supply was not working properly. I hope so. Let's take a look now. I'm gonna take a look at the diagram there and see how this protection, how this Zener is wired. Yeah, if we look here, the Zener, this resistor is broken, there is nothing forcing the gate of this SCR to ground. So I am guessing that it's going to be very easy for this SCR to get triggered, right? And maybe this is what is happening. I don't know, because I saw 5 volts there. Did I? I think I did. So yeah, but let's take another look. I think I'm going to reassemble everything and we are going to make more measurements. I would do that. I was going to do that anyway because I said that maybe before we do that, we can just take a look at these capacitors on the 5-volt rail just to make sure that they're all good. Yeah, and then I'm just gonna check these capacitors and then connect everything back again and see how it behaves. Okay, we have now the machine partially assembled, let's put this way. I have here the backplane and the cards here. I left one of the RAM cards out. What else? The power supply is there. The screen controls are there. CRT analog board is here. Everything is connected. The power. I didn't connect the floppy drive yet, and the power for it is here. I'm not gonna use it for now. Fingers crossed. Yeah, let's power it on. Oh, I'm hearing the flyback, and there is light there. There is signal on the monitor. Cool. And yeah, now the front panel, the LED is working. Good. So the power supply was bad. Oh, and I see some kind of, it's a cursor blinking there. This control is not working. I don't know why. Well, okay, I'm gonna power it down and I'm gonna try to turn the machine to the camera so that you can see. But yeah, this is starting to look good. And power it on. What? Now it's not working. Seriously? What could be wrong? Now I can hear I can clearly hear the power supply turning on, and there is light all the time. I see the glow on the electron gun, and I didn't know, but this is a white phosphor screen. I did not know that. But the scope is there. Let's take a look. I'm gonna power it on. Oh, and there is a sync. 15.58 kilohertz. Oh, now there is. Oh man. Okay, I don't know what is happening. Now there is a signal on the screen again. You can see here, right? Yeah, see how my... Man, I don't want to move it. But, let's power it off. Okay, and power it on again. And now there's no sync anymore. What is wrong? The voltages are okay. See, 498, 12.41 minus 1198. Yeah, that's pretty good. According to the manual, well, we can start by looking at the voltages, right? Let me take a look at the voltages on the logic ICs. Do we have? Yeah, we have a good 5 volt there. Let me measure there. Yeah, 5 volts, pretty good. Let me check the clock to the Z80. I think it's been 6. 1, 2, 3, 4, 5, 6. 3.997. Yeah, 4 megahertz. Yeah. Let me just. This one? Yeah, 4 megahertz. So we have clock. No signal yet. No. What else we want to see? Reset. Reset, according to the manual, is TP11. This guy here. Oh, that does not look good. It's almost like it's floating, but it's floating high. Do we see? Oh, okay. Yeah. Good. So we see the reset happening. See? Let me change it to the, let's change the trigger to normal falling. Now if I press reset, we're gonna see stable. See? Reset there. And we can even measure how big, 1 millisecond per division. See, there we have it. The reset takes like 150 microseconds. Yeah, kind of. Yeah, something like that. Okay. Now let's go back to auto because I want to keep seeing stuff. So okay, this switch works. The reset seems to be working. I don't like the fact that is, but it's floating high, so that's not a problem. What else could it be? Let me move it all the way there. Can we make it work again? Oh, see? Yeah. I don't know what is wrong. Maybe it's... No, I don't think it's any of this. And it's not the power supply, because I'm not moving anything. Like here. Yeah, see, the screen comes on pretty quickly. So it's either here or here. But I don't see any problem when we... So this one, this potentiometer is working and we control... I don't know what is this. It's... Oh, but there is something on the screen. Cool. So that means that the logic board is working. Yeah, I see a cursor. This one is not working. So this is probably... Oh, wait, there is... The resistor is lifted there. right? There's a, I didn't fix that. Completely forgot about that. Huh. That. Now let's take a look. Oh, I think it's gonna be safe to just turn it while it's working. A little bit, maybe. Oh, I don't want an accident to happen. Yeah, well, I didn't fix the yoke, so I need to attach the yoke, but yeah, this, and it's out of focus. Oh, and now something else happened, but I still see the cursor there. Let's see if the reset switches solves that. Yeah. Oh, nice. Wow. I still don't understand. Well, okay. Yeah, I'm start to just. First, we need to fix this appearance here, and I need to understand why this guy is not working. So it could be either that. Oh, 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 okay. Yeah, it's broken inside. That is why it's not working. And now, insert diskette. Awesome. Yeah. Worst case, I'm gonna have to buy a potentiometer like this. I don't know if that is gonna be easy or not. And I thought that it was out of focus, but no, it is really good and focused, the image. Let me see if I can turn it a little bit towards the camera. Insert diskette. Yeah, I think now you can see, right? Pretty cool. So now we know that this is all working. There is something, but I would want to say that this is minor at this point. I need to track down the source of the issue that causes it to not. Let me see, probably it won't work. Oh no, it did work. Okay, yeah. Man, I'm super happy. I thought, honestly, I wasn't expecting it to work. I thought there would be a lot of problems on these boards, and I was like, oh man, it's gonna be hard to, because you can't test stuff individually, right? Oh, why this is so dark? Yeah. Anyway, it is working. Oh, probably because of this. Yeah. It is like all this stuff here is working. That is awesome. The CRT is also working now, and for for some reason that resistor that has the one of the leads cut and lifted, it's not necessary. I don't know why, but at this point I am not gonna question, and I'm not gonna try to fix, because it is clearly working, right? Oh yeah, this, yeah, this is working. It's just that this is the brightness, right? Let me. Oh, okay. Lots of garbage. It's like it didn't reset properly. Oh, it's different now. Even the reset is not working. Let's power it off. Is 150 microseconds enough? I have a feeling that the reset should be longer. Let maybe I'm wrong. We have 4 SRAMs there for the video. Okay. Yeah, I'm gonna have to remove all the chips that are on sockets and clean them up. But the good news is that one potentiometer works, the other doesn't. But the machine is working. Well, part of the machine, right? Most of the machine. We didn't try the floppy drive yet. But I don't really want to assemble it all again and risking having to disassemble it to find the fault that is causing it to not always work. Yeah, well, if it's just the boards, it's easy to reset everything. Yeah, it's working now. But that's it for this video. It is already too long and there's still a lot of stuff to do. So on the next videos, we're going to take a look at fixing this intermittent issue. Also imaging the boot disk so that we can try to boot up the machine and see if the floppy drive is working. I'm also going to have to reset and clear all the contacts of the ICs, because we already saw that there is some bad contacts happening there. And then also take a look at the keyboard. I hope you enjoyed this video, and if you did, please give me a thumbs up, subscribe to NMI, and see you next time. Bye!